So the braking distance is the distance a car travels before coming to a complete stop when the brakes are applied. Braking distance is a quadratic function of the initial speed of the car. What's the average increase in braking distance for each mile per hour of increased speed between 40 and 60 miles per hour? So this is basically asking your average rate of change. What's the average increase for the intervals 40 to 60? So then from the table, I'm going to look at where the intervals are 40 to 60. And I know it's hard to see, so I'll write them off to the side. But for these average rate of change problems, they're always going to tell you where they want you to look, because not necessarily is the average rate of change the same throughout our exponentials or quadratics. So they want it from where x is 60 and where x is 40. So these are my two coordinates that I'm looking at from the table. If it was a graph, then I would look at the graph, those coordinates, and things like that. Average rate of change has a very specific formula. Anyone remember what it is? This would be something I put on my note card. So that would be y equals mx plus b is linear functions. Average rate of change would just be like the slope. So how do I find the slope between 2 points? That's the same as my average rate of change. Anyone else want to venture a guess? It's something that you'll see over and over again. Maybe since it wasn't on these most recent unit tests, we forgot, but it's something you will see for the rest of your high school math. So the sooner you have it memorized, the easier your life will be. But it's the same as our slope formula. The way that it works is you use this formula, label one of your coordinates as x1, y1, the other as x2, y2, and plug it in. So the way that I labeled it, I'd be doing 172 minus 76 over 60 minus 40. Because you want your average rate of change. Your change in your y's divided by your change in your x's. So definitely I would add that to my note card. And simplify it, 172 minus 76 is 96. 60 minus 40 is 20. 96 divided by 20 is 4.8. So it is changing on average 4.8 feet for every mile per hour, or however they're doing it. Okay, so like feet per every. Does that make sense? Any questions? All right, any other questions? If it's from the quizzes, you might have to describe it to me, or if it's from the puzzle piece, tell me. Don't ask, and I guess you don't know. All right,